Hey people, welcome back. And in this session, we will learn about the test for association, where you have the two categorical variable. You have the variable 1 and variable 2, and both are categorical in nature. You wanted to find out are they related to each other or not, or there is any statistical relationship between these two variables, yes or no. We wanted to find out, then we use the test of association. It's a part of the chi-square family when you have the two variables and you wanted to figure out either they are related to each other or not. Suppose I have a data for this. Maybe let's say you have a data here, like as suppose you have the students in your class, or maybe these are you can consider as a machine. You can consider like as machine, the machine is running on the standard speed or the reduced speed, then it has generated no defect or it has generated the defect. Or maybe the machine maintenance is done or not done, versus the breakdown happen or no happen, unscheduled breakdown. Or maybe that you are eating a standard lunch or you are eating a reduced lunch. Does your lunch really have a relationship or association with the test preparation you have done or you have not done? Does your food habits impacting your test preparation, yes or no? Then we can find it out here. So when you have the two categorical variable and you wanted to run, you wanted to find out a relationship between these two categorical variable, then we perform the test for association. How do we do this? Let me do one thing. We'll go to the mini tab here. And in mini tab, I just paste this data. We remember null hypothesis, which means there is no difference or no relationship between these two variables. Alternate hypothesis, p-value is less than 0.05, which means these categories are not independent. One, maybe your lunch habit is impacting your test preparation. How to do this? We'll go to the stat, tables, and in table, we will click on the test for association. Click on this. It will ask you what is in the rows you want to see. Maybe in the row, I wanted to see the lunch. And in columns, I wanted to see the test preparation. Are they equally distributed or not? We'll go into the statistics option and we will select each cell contribution to the chi-square. That will help us that which particular category is on the lower side or upper side. That's all. No need to worry about the options. Let it be as it is. And just click on the OK. And you will see the results are in front of you. First thing we'll look for the p-value. So likelihood ratio for p-value is 0.590, which means it clearly says that there is no relationship at all. That what kind of lunch you are eating versus the test preparation you are doing or not doing are completely independent from each other. They are not at all depending on each other. The first line represent for the reduced lunch, second reduced for the settings shows for the standard. This is for completed. And here you see in the last bottom, the first one will represent the count, actual observation. Then expected count is the 127 and 227. And the contribution to the chi-square is 0.12 and 0.06. This is for the reduced one. So I have the total observation here is 1000 observation, out of 355 are from the reduce and 645 for the standard. Out of 355 reduced, 131 has completed the test preparation. 224 did not complete the test preparation. This is the actual number, where as per the chi-square calculation, I was expecting that 127 should have completed the test preparation instead of 131. And 227 should have not completed none out of 355 as in 224 against the 224. So there is a minor difference. Contribution to the chi-square is very low, less than nearly 0.1, which is negligible. The similar way we look for the standard lunch. 645 are using the standard lunch. Out of 645, 227 completed the test preparation and 418 not completed. Against the 227, my expectation was 230 numbers. Against the 418, expected was 414. Again, there is a very minor difference, and that's how the contribution to the chi-square is very low. If contribution to the chi-square is low, then p-value will be greater than 0.05 as the contribution to the chi-square will increase, which means the contribution to the chi-square will increase when the difference in the actual and the expected will increase. Higher the difference, higher the contribution to the chi-square, and that's how statistically difference may come, and p-value will be less than 0.05. This is the way we try and find out, is there any difference in the expected and actual when you are comparing two categorical variables. And this is the way we perform the test for association. Thank you so much, people, and I will see you in the next session.